All right, so in this video, we're going to go through the answers to the practice 2.5 day 2. Our very first proof, you can see we are given a square, and you're given the fact that D is the midpoint of segment AE. So let's go ahead and take a look at the very first clue. It says ABCD is a square. So if this is a square, that would mean all 4 of these segments must be the same length. So we could say that segment AB is congruent with segment BC and also that's congruent to segment CD, and then of course our last segment AD. So I'm going to label that step 2, and our reason here is going to be the fact that it is a square, so we're using definition of a square. Okay, so taking a look at our second clue, it says D is the midpoint of segment AE. So I'm going to go ahead and erase this so that way I can give you guys that visual of what's going on. So if we know that point D is the midpoint of segment AE, we would know that segment AD is congruent with segment DE. Right? Because midpoint means it's the point in the middle. So we're using the definition of a midpoint to state that those 2 segments are congruent. Now, whenever we're done with this, we've used up both of our givens, you always want to look in your proof. You'll notice in this proof that we have something that's repeating. AD and AD is in both statements. So since AB, BC, and CD, those 3 segments, are all congruent to AD, and AD is also congruent to DE, we can state that all 4 of the remaining segments besides AD are congruent to each other. That is called the transitive property. So I'm just rewriting what I have here. Now, if we look at what we're trying to prove that DE and AB are equal, not congruent. So we want the length from D to E, which DE is here, and the length from A to B, which AB is here. So since segment AB is congruent to segment DE, the length between D and E would be equal to the length between A and B. So we can finish our proof. We can say that DE equals AB, right? Congruent. If we have congruent segments, right, if segment DE is congruent to segment AB, then they have to be equal, right? Congruent means that they're the same, they're equal. So our reason over here is going to be definition of congruent. Okay? Okay, so on to number 2. So in this one, again, we're looking at the clues. This first clue is that ray BC bisects angle ABD. So you have to remember what bisect means. You have to remember the definition of an angle bisector to use that clue of our given. So bisect means to cut in half. So if we're looking at ray BC is cutting in half angle ABD. So from there, you should see 2 angles, and we want to say that those 2 angles are going to be congruent since they were cut into 2 equal halves. So the angle on the left, we name angle ABC, and then the angle on the right, we're going to name angle CBD. Okay, so once again, remember naming it AB. The middle one has to be the middle letter. ABC is congruent to CBD. All right, so we just used this clue, the fact that ray BC bisects angle ABD, and now we're going to use this clue. So now we're looking at ray FG. So ray FG is going to bisect angle EFH. So again, this ray is cutting in half this angle. So we have two angles now that we can say are congruent using the definition of an angle bisector. So the angle on the left would be EFG. So angle EFG is congruent to the angle on the right, which is GFH. All right, so we used up our givens. The reason why I say that is this is a clue and so is this, but this is not a clue. This is a statement. It's just stating angle ABC is congruent to angle GFH. So we're going to use that in just a moment. So often in class, you guys will see me zoom in. So I'm going to go ahead and zoom in on just these statements. The reason why I zoom in is because I want to draw attention to the fact that we have some angles that repeat. Right? Angle ABC is congruent to angle GFH. Angle ABC is also congruent to angle CBD. And angle GFH is also congruent to angle EFG. So these all connect. This is the transitive property. So that would mean I'm left with two angles, CBD and EFG, that are congruent. And that is called the transitive property. Whenever you cross them off, basically it's like if A equals B and B equals C, then A must equal C. It's the same idea here. We just did it with 3 statements instead of just 2 statements. Okay, so our next proof here, we're given that angle 1 and angle 2 are complementary. So you need to remember what complementary is. You need to remember what the definition of complementary angles are. So that way you can actually write something down for step 2. So remember, complementary angles are 2 angles that add to 90 degrees. So we can state that the measurement of 1 plus the measurement of angle 2 equals 90 degrees using the definition of complementary angles. Now, we're stuck because that was the only clue we were given in our given. So whenever you are stuck when doing a proof, you look at the picture. Okay, so we're looking over here. You should notice a certain type of angles every time. Hopefully we all notice that we have special angles right here. These are called vertical angles. Vertical angles are formed whenever 2 straight lines intersect. And those angles happen to always be the same exact measurement. So we can state that the measurement of angle 2 is equal to the measurement of angle 3. That is called the vertical angle theorem. It states if you have vertical angles, then those vertical angles are equal. So now that I know that 2 and 3 are going to be equal to each other, I can again look at my proof. I'm zooming in again, and I want you to notice that they both have angle 2 in them. Now this is not transitive property like we did before. This is instead substitution, because we're going to replace angle 2 right here with angle 3. So since angle 3 is the same thing as angle 2, we're going to replace angle 2 with angle 3. This is not transitive property because of this. Because angle 2 is being added with angle 1, I can't just like cross these off like we did before. It doesn't work that way. This is called substitution because we're replacing this 2 with a 3. So our next step, step 4, is going to be the measurement of angle 1 plus the measurement of angle 3 equals 90. So we're basically rewriting step 2, but replacing the 2 with angle 3. Okay, and again, that was called substitution property. So if angle 1 and angle 3 add to equal 90 degrees, then aren't angle 1 and angle 3 complements? So we can finish off our proof here with this last step. So since the measurement of 1 plus the measurement of 3 equals 90, angle 1 and angle 3 are complements. that is simply just using the definition of complementary angles that states two angles add to 90 degrees. All right, so we have our last proof here from this homework set. We are told that ray EB is a bisector of segment AC. We're also told that segment FG is a bisector of segment BD. So let's look at each clue independently. So looking at that top clue, we've got ray EB that is bisecting segment AC. Remember, bisect means to cut it into two equal or congruent parts. So that would mean that this segment on the left, segment AB, must be congruent to the segment on the right, which is segment BC. Okay, so that is using the fact that we bisected a segment. So we're using definition of a bisector, specifically definition of segment bisector, not angle bisector like we've done before. We're bisecting a segment, not an angle. All right, so we just used up our very first given here. So now we're going to look at the second given. FG is a bisector of segment BD. So I'm going to go ahead and erase the picture with the coloring so that way you can again focus on just that part. So we're looking now at segment FG that bisects segment BD. So since it's cutting it in half, that would mean that this segment BC, that half, is going to be congruent to this segment CD on the right. Okay, so we used up both of our clues. So whenever you use up both of your clues, I'm always zooming in and saying, what do you notice? Well, what do you notice? You notice that BC is repeated. So we can use the transitive property again to put AB and CD congruent to each other. So segment AB is congruent to segment CD. All right, so since they're congruent, they must be equal because congruent means they're the same. So AB equals CD using the definition of congruence. All right, that's it, you guys.